Alright, welcome back everybody. In this video we're going to talk about writing equations when we're given 2 points. Okay, so we know 2 points that the line goes through. If we want to write an equation when we know 2 points, the first thing that we've got to do is find the slope. Because we always, no matter what, to write an equation in a line, we really need the slope. Then we're going to use the slope and one of the 2 points to write the equation. So here's our example. We're going to write the equation in slope-intercept form of the line that goes through these 2 points, negative 3, 5, and 1, negative 3. So the first thing I'm going to do is I'm going to go ahead and calculate the slope using these 2 points, set up my slope formula, make sure I align the coordinates from the same points, and I make sure I put my y's in the numerator. Other than that, the order doesn't matter. And I go ahead and I find that the slope is negative 2. Now, we want to write our equation, our final equation is going to be in slope-intercept form, but what I'm going to do is I'm going to pick one of these points and the slope, and I'm going to go ahead and write the equation that way. So I've got y minus the y coordinate is equal to the slope times the quantity x minus the x coordinate, so x minus negative 3 becomes x plus 3. And now I'm just going to convert this equation over into slope-intercept form. And I add 5 to both sides. And there I am. I have an equation in slope-intercept form. Now at this point in time, some people might be like, well, Mr. Thomas, I didn't want to pick the point negative 3, 5. I wanted to pick the point 1, negative 3. Won't I get a different answer? And while we might start with a different answer, when we convert it over into slope-intercept form, we'll end up with the same answer. And I just want to show you that that's the case. You know, we already have our equation, we found it. But just to kind of show you what would have happened, a what if here, if I had taken that point instead with the same slope, we would have had y minus the y coordinate is equal to the slope times x minus the x coordinate. And you'll notice that these two equations look totally different when we set them up. This equation for the one point and this equation for the other point. And this is where slope-intercept form becomes the great equalizer. We distribute. We get this. And now we're going to subtract 3 from both sides. And lo and behold, we get the exact same equation. So the lesson to take from this is that it doesn't matter which point we choose. If we find the slope and we pick one of the 2 points and then we write our equation and convert it over to slope-intercept form, we're going to get the same equation for these no matter what. So pick whichever point you like. Doesn't really matter. Alright. We're going to do that with these 2 examples just to get it under our belt a little bit more. So we're going to write the equation in slope-intercept form of the line that goes through these points. Let's look at example A. First we're going to calculate the slope. I put my y's in the numerator and align my coordinates from the same point. Same thing there. I get 6 over 3. So my slope is equal to 2. And then I pick one of the points. Doesn't matter which one you pick. I'm going to pick the first one. I've got y minus 5 is equal to the slope times the quantity x minus 4. And now I'm going to convert that over into slope-intercept form. Distribute the 2, add the 5 to both sides, and boom, we're in slope-intercept form. We'll do the same thing in example B here. First we'll calculate the slope, put our y's up in the numerator, and align coordinates from the same point. Oh boy. Our slope is negative 7/9. And now I want to pick one of the 2 points. You know what, just for variety's sake, this time I'm going to pick the second point. Again, doesn't matter at all. So I'm going to take y minus the y coordinate is equal to the slope times the quantity x minus the x coordinate, and x minus negative 3 becomes x plus 3. And now we need to distribute. So I'm going to distribute the negative 7/9 through the parentheses. If you have trouble with taking negative 7/9 times 3 and you're not sure what that's going to be as a fraction, you're always welcome to go ahead and just take negative 7/9 times 3, and then we'll change it over to a fraction. It gives me negative 7/3. And then I'm going to add 5 to both sides. I'm going to go ahead and do that fraction a while. Ends up being a positive 8/3. So we end up with y equals negative 7/9 x plus 8/3. Okay. Alright, and on to our last example. We're going to look at a word problem scenario. Jose is hiring a band for his wedding. The band charges a transportation and setup fee, and then an additional hourly charge to perform. The band charges $220 for a 3-hour set and $300 for a 5-hour set. Write an equation that models this situation with x representing the number of hours and y representing the cost. So our ordered pair in this situation, x is the hours, y is the cost. So I can write ordered pairs based off of the two pieces of information that I have. Band charges $220 for a 3-hour set. That's the ordered pair 3, 220. And the band charges $300 for a 5-hour set. That's the ordered pair 5, 300. And now we can calculate the slope. And we make sure that we have our y's in the numerator and we align the coordinates from the same point. I keep saying that, align the coordinates from the same point, but notice that those coordinates line up in our slope formula and these coordinates line up in our slope formula. As long as that happens, it doesn't matter which point we put first in our slope calculations. The order is completely unimportant. And then we get 80 over 2, or 40 for our slope. And now I need to pick one of these 2 points and write an equation. I'll pick the second point, the yellow highlighted one. So I've got y minus 300. And again, there was no real decision-making process there. I just randomly picked one of the 2 points. You could just as well have picked the other one. Equals 40 times the quantity x minus 5. And now I want to, well, I have an equation that models this situation. A lot of times I'll ask for this equation in slope-intercept form, but sometimes I won't. This would be a totally valid answer to the question, write an equation. But I'm going to go ahead, since we have, the time, and convert this over into slope-intercept form. I distribute the 40 through the parentheses, and I add 300 to both sides. And here's another form of the equation, slope-intercept form, that represents this scenario for Jose and the band that he's hiring. Alright, that's the end of this video. I'll see you guys next time. Have a great rest of your day.